angle of minimum deviation. Since we have studied already, we have seen in the previous lecture, that is angle of deviation is equal to I plus E minus A, which is equal to I plus sine inverse of mu sine of A minus sine inverse sine I by mu, the value of E is this one, minus the angle of prism. So from this, since for a given prism, angle of prism is constant, refractive index is constant, therefore deviation is function of I. That is deviation angle depends on angle of incidence. When we see, when by experimentally it is known that when angle of deviation plotted against the increasing value of I, against the increased value of I, that is I, this is angle of deviation, when angle of deviation plotted. So initially the angle of deviation, as the angle of incidence is increased, the angle of deviation decreases as angle of incidence is increased, and further it increases. At this value, the angle of incidence is equal to angle of emergence. There are both angle of incidence and angle of emergence, both are equal. For a given value of angle of deviation, there will be two values, I1 and I2. I1 and I2, which is equal to I, this is equal to E. It means at minimum angle of deviation, at certain value of incidence, at certain value of angle of incidence, the value of angle of deviation takes the minimum value. That is, when angle of deviation is equal to minimum angle of deviation, at that instant angle of incidence is equal to angle of emergence. So at this stage, so we can say the refractive index is given by sine of I by sine of R1, which is also equal to sine of angle of emergence divided by sine of angle of incident at the second phase, that is R2. So since at deviation is equal to deviation minimum, then I is equal to E. Therefore we can write mu is equal to sine of I by sine of R1, which is equal to sine of E. Since E is equal to I, we can write sine I into sine of R2. It means sine I, this side, this LHS is equal to RH, this is equal to this one, it means R1, and we can say sine of R1 is equal to sine of R2. That is, R1 is equal to R1 is equal to R2. R1 is equal to R2. It means at angle of deviation is minimum, that is angle of deviation minimum, angle of incidence is equal to angle of emergence, then R1 is equal to R2. We can say R, since both are equal value. In that case, since, and we know A is equal to R1 plus R2, R1 plus R2, or we can say A is equal to R plus R, or A is equal to 2R, which means R is equal to A by 2. Also, minimum deviation, at minimum deviation, I, angle of incidence plus angle of emergence minus A. This is the formula. At deviation angle, angle of deviation is minimum. At minimum angle, we can write I is equal to I. Since angle of emergence is also equal to angle of incidence at the first phase minus E. Or we can write 2I is equal to angle of incidence plus angle of the prism plus angle of minimum deviation. This we can write this way. Then I is equal to A plus angle of minimum deviation divided by 2. So once it's divided by 2, then we can write mu is equal to sine I by sine R1, or also we can write sine of angle of emergence is sine of R2. So sine of I, what is sine of I? Sine of I is equal to A plus minimum angle of deviation divided by 2 divided by sine of R, sine of R1. R1 is nothing but sine of R. Since R1 is equal to R2 is equal to R, we can write sine of R. Sine of R can be replaced by A by 2. A by 2. So this is the relation, mu is equal to sine of A plus angle of minimum deviation divided by 2 upon sine of A by 2. At this instant, since this is the prism and ray going this way, this is a normal one, and the rays will be parallel to the prism, base of the prism, A, B, C, and after refraction through this AC, it will go like this. It means the angle of incidence and angle of emergence both will be symmetrical with respect to the phase AB and phase AC. It means these and these are symmetrical. Since I is equal to E, it means this ray is symmetrical with respect to phase AB and phase AC. And the ray through prism is parallel to base, that is BC, base of the prism. It means the ray inside the prism will be parallel to the base side, that is BC, and the incident ray and emergent ray are equal, and this incident ray and emergent ray will be symmetrical with respect to AB and AC. So we can come to the relation. We can write angle of refraction, that is the relation between refractive index and angle of refractive index and angle of prism and angle of minimum deviation is equal to sine of A plus angle of minimum deviation divided by 2 upon sine of A by 2. Therefore, at minimum angle of deviation, that is angle of deviation is equal to dou m, dou minimum, angle of incidence is equal to angle of emergence, the angle of refraction at the first surface, the angle of refraction at the first surface. This is ray incident here, this is normal, this is ray through the prism, and again normal, and it will be like this. So the ray will be symmetrical with respect to phase AB and AC. In angle I, this is angle of emergence, angle of incidence, R1 is equal to R2 is equal to R, and refractive index of the prism material is equal to sine of A plus angle of minimum deviation and divided by 2 divided by sine of A angle of prism, where A is equal to angle of prism, and the general formula is rho is equal to angle of deviation is equal to I plus A minus A, and which is turned to in this condition at when rho is equal to angle of deviation is equal to minimum angle of deviation. At this stage, I is equal to R1 and R2 is equal to R. General IA is equal to R1 plus R2, and this is the relation when the ray, incident ray and emergent ray goes this way, it suffers minimum angle of refraction. This is the emergent ray, this is the direction of ray, and this is the angle, rho minimum.